I love playing around with new models, and we've been playing a lot with latest YOLOv8 on this channel, training both object detection and instance segmentation model. However, the moment that it gets super exciting for me is when we put those models to the test and build something useful with them. And today we'll build object detection, tracking, and counting system. It may seem hard, but with the right tooling, it's like connecting small Lego blocks. So today we'll use latest YOLOv8 for object detection, state-of-the-art ByteTrack for tracking, and latest library from Roboflow called Supervision for counting. We'll go through two use cases. The first one, very stereotypical, is counting cars moving on a street. The second one, a lot less stereotypical but very much real, is counting objects moving on a conveyor. And the coolest thing about it is that we will use exactly the same code in both cases. So there is a very high chance that you would be able to straight away reuse it in your project. So before we start, make sure to hit the like and subscribe button. It helps the channel a lot and helps me to stay motivated, which is very important in long projects like this. So without further ado, let me show you how to detect, track, and count using computer vision. One more thing. That video is very long, most likely the longest I ever recorded. So don't hesitate to use the timestamps below to navigate to the part of the video that is most interesting to you. Like with all our tutorials, we start at the Roboflow notebooks repository and we scroll this time a little bit lower, not into models tutorials, but into computer vision skills. And over here, there is a new notebook, track and count vehicles with YOLOv8 ByteTrack and Supervision. So let's open that and go collab. As usual, we created a notebook, but I decided I will not use it. You can still follow it in the meantime. I decided the biggest value that I can give you is not to go through the notebook. It's to show you how you can go from I have the video into I have a working computer vision system that can detect, track, and count objects. So that's why I will create a copy of this notebook, remove everything that is not installation of libraries or downloading the data, and we'll see each other in just a bit. Okay, like I said, the copy is created. Let me just start by increasing the font size so you would have easier time following the tutorial, and we are good to go. Let me scroll through that introduction of maybe the most important part that is worth mentioning is that YOLOv8 is still under heavy construction, so we need to be cautious. It's better to have a specific version of the library pinned because your code that you are currently developing can break at any moment. So let's start by executing NVIDIA SMI. We just want to confirm that we have access to GPU. Those computer vision models work significantly faster if you execute them on a GPU instead of a CPU. Takes a little bit of time because the environment needs to be set up, but we have it. Tesla T4 is here. Next thing is to create home variable just to make it a little bit easier for us to manage paths and always know where we are. With time, I get to appreciate that working pattern, so I can only encourage you to also implement it. The next stage is to download the video that we'll be using. So this is the video of cars moving on the street. Nothing very unusual. You saw it in the intro already, and we'll use that as an example. And now the installation of YOLOv8. We have separate videos on YOLOv8 when I go very deeply into installation and CLI and SDK. You most likely see that video in the top right corner right now. You can also find it in the description below. Like I said, it's good practice to have a specific version of YOLOv8 pinned because they are breaking API on a daily basis right now. I will try to make that notebook work with the latest version, regardless of the moment when you are watching that video. But for your sake, it's much better to pin it so that you wouldn't need to fix that later on your own. Next thing is installation of ByteTrack. Contrary to YOLOv8, which right now has pip package and SDK, ByteTrack is packaged terribly. So we need to go through a lot more steps. Over here, you see we use version 0.1.0 of ByteTracker. The last part is Supervision, my little baby. So be gentle. No, I'm just joking. If you see any problems, something doesn't work for you, for your specific use case, make sure to create an issue on Supervision repository. Same for notebooks. If you see that something doesn't work, don't hesitate, create an issue, and we'll try to help you out and solve the problems. It seems that we were using test PyPy. Let's change it to a regular one, so just remove this. And like I said, it's always better to pin the version. Especially with Supervision, we are still in pre-release stage. The API may change dramatically by the time that you will watch that video, but if you will stick to the version 0.1.0, you most likely won't face any problems because it's already deployed in pip package manager. So let's just hit enter. Works. I was in stress for a second. Whew. Honest mistake, guys. Honest mistake. Now we can load pre-trained model just to confirm that everything works. Okay, and we have everything ready. The first thing that we can do without any effort, basically, is just to run YOLOv8 CLI on that video. That will give us the feeling whether or not our model is strong enough. So let's do that. Let me just copy and paste the line with example prediction. But what we'll be doing is we'll be using task detect mode predict version X of the model, and we'll pass our video as the source. So we created a temporal variable over here that we can right now use. Let's do it like this. Press enter. Now when that is done, we can go to runs, detect, predict, and we have the result video that we can download. Jupyter Notebook is notoriously terrible at doing that fast, so I will just use the magic of cinema. Let's take a look at the results. Detections are looking pretty stable. We get some random here and there, but nothing that we wouldn't be able to filter out. So I'd say we are good to continue. CLI is great when you want to do something typical, but the moment that your use case become a little bit custom, you pretty much need to migrate to Python scripting. So that's exactly what we are going to do. We will use Supervision to recreate the inference loop, which is, by the way, one of the most frequently asked questions over the last few months is how do I run a model on every frame of the video? Now I have pretty much one-liner answer for you. And then we will use YOLOv8 model imported from Python SDK to run inference inside that loop. In the meantime, I will do my best to explain how Supervision utilities work. We don't yet have documentation, so I decided to go one by one and explain how to connect everything together. First thing first, let's start with frame generator. This is a piece of code that will allow us to read frames from video, but one by one. So instead of loading them at the same time into the memory and most likely running out of RAM really fast, we will just load one frame at a time. Supervision have a dedicated method that we can use to do that. It's called getVideoFramesGenerator. So that method takes only one parameter, and this is the source video path. Obviously, we need to import that utility from Supervision. How do we use that? You just do something like this for frame in generator, and you can basically use that frame inside that for loop. However, for now, we will not use it this way. We will just pick one frame, and I will explain everything on a single frame, and then we will put that inside that for loop. If we would like to pick just one frame, first, we need to create an iterator. It's pretty easy. We just call iter on the generator. Then we can pick the next frame. At this point, if I would print the type of this frame, you would see that it's a NumPy array, something that we would expect. That's usually what we use to store images. Now, if I would like to print that frame inside Notebook, we also wrote a small utility to do that. This is show frame in Notebook, but everything is explained in pretty straightforward language, so I hope you will manage to use that on your own. Obviously, like in the previous case, we need to import that particular utility inside the Notebook. So let's do that. And at this point, we are basically able to pick a single frame from the video and display it in the Notebook. Next thing that we can do is to run the model. For a second, let's comment this out. Let's add results, model, pass the frame, and that will return a list of predictions because you can pass a list of frames or a NumPy array of frames. Because we are passing single frame, we will retrieve the first element from that list, a result object that is coming from YOLOv8 pip package. I can now do boxes and, for example, XY, and that will return PyTorch tensor containing the locations of objects on the frame. To work with supervision, we will need to convert that into NumPy arrays. We also have confidence. We see values between 0 and 1, or classes. Supervision is a general purpose library, so we need to convert what we get from YOLOv8 to an object that is understandable by supervision, and that object is detections. So let me just copy the boilerplate so that we wouldn't waste a lot of time. And because I already picked the first element from results, I don't need to do this. Box annotator is another class, and this class can be used to display bounding boxes on frame. We already imported detections and bounding box annotator. So let's now create an instance of bounding box annotator. That instance, what is important, takes color palette, something that we also need to import. Color palette is basically a set of colors that will be used by that particular annotator. And at this point, the only thing that we need is to annotate frame with those detections. We pass raw frame, pass detections, pass labels, but I will skip that for a second. And right now, if I will uncomment show and just run that, we will get annotated frame with bounding boxes and, in this case, probabilities. But I may, for example, don't like those probabilities. I would like to have something more custom. What can I do? So we could, for example, print class ID, no problem. How can we do that? We can pass additional parameter to annotator called labels. It was here before, but I removed it. If, for example, I would like to just print class ID and confidence, I could do that. I can just do something like this, and the annotations have been updated. Right now, I see class ID of my detection and its probability. That's not really useful because humans work much better with text than with numbers. Models in YOLOv8 contain property called names, and we can map our class IDs into those class names. So let's just create a constant that will store that dict for us for a second. And right now we can map our labels differently. And basically, instead of printing class ID, we will map that class ID into class name, and I can print that. And in just a second, I should see that it's a track with 93% of probability. So this is the example for a single frame. The next step is to convert that into processing the whole video and then adding additional layers of complexity with tracker and counter. Now, like I said, if we want to convert code that works for a single frame and run it on a full video, we need to loop over video frames coming from generator. Instead of just picking a single frame with next, we will use for loop. So we can do it the easy way, like this, for frame in generator, and just indenting everything by a single tap. And that code would basically print every frame for us like it's doing for that single frame below. What we would like to do is to save all those frames in the form of the video, and that is possible with another class that we have in Supervision library that is called video sync. Let me just copy that into the notebook. And now if I indent it one more time, video sync expects two arguments, the path to output file and the instance of video info class. If I will just paste that single line and also import, now I should be able to get a little bit more information about the source video that we were using. I know, for example, the resolution, the FPS, and the total amount of frames. And that information can be passed to video sync so that it can create a output video file with the same video resolution and the same FPS. Right now, we should save that video info to a separate variable. And that code is pretty much ready to run the model on every frame and save the results. The only thing that we still need to do is to remove show frame in notebook, because we don't want to print those frames. We want to save them. So video sync has a method to do that. It's called write frame. With that small change, we are basically ready to process the video. There's also one more thing that we can do. Easy way to loop over frame is just with for loop, but when I'm processing long video files, I would like to know my progress. We could use tqdm, which is Python package that creates those very nice looking loaders. tqdm requires something that it can iterate on, and the amount of total items that we are going to iterate over. Because I already created video info instance, I know the total amount of frames in my video. Right now, I just need to import tqdm and I should be good to go. Just remember to import tqdm notebook version, because there are different versions for terminal and for notebook. We can now press Shift Enter and just wait for the video to get processed. So far, so good. Now that we have that part done, we can think about plugging in the tracker. In the past, we used ByteTrack with YOLOv8 to track football players on the field. So if you want to learn more, feel free to watch that video. The card should be visible in top right corner right now. But today I will just copy the boilerplate, plug in the tracker into our pipeline, and focus mostly on counting. Okay, so we are back in our Jupyter notebook. At this point, our main objective is to plug in the tracker. The tracker itself is already installed in the environment, so there is nothing really stopping us from creating an instance of that tracker. So let's do that. Maybe a little bit over the generator. The tracker takes arguments that are in the form of a Python class. That class was defined just a cell below the installation code. And as I said in the YOLOv8 video, there is a small problem with matching predictions coming from YOLO model and the expected positions of objects with given IDs that are coming from ByteTracker. So there is a little bit of boilerplate code that we need to copy and paste. So once again, if you want to understand more from that section, I highly encourage you to watch that video. For now, I'll just paste it over here and forget that it existed. And we'll just use it inside our main for loop. As I said, we created an instance of ByteTracker just over our main for loop. And here I'm using that instance to acquire tracker IDs. All that seems pretty complicated, but it's really not. It's just something that needs to be there, so don't get overly intimidated by that. And finally, we can update our labels generation, include not only class ID, not only confidence, but also tracker ID. Let's run that code and take a look at the results. Slowly but surely, we are getting somewhere. Our previous output just got enriched by tracker ID. And the only thing that's left is to draw the line and count objects that are crossing it. That part is actually pretty easy. The only thing that we really need to think about is the location of the line. So I spent a little bit of time pinpointing the right location. And I came up with those 2 points. Let me just maybe paste them over here. And we are using class coming from Supervision library called point. So I need to import it so that we wouldn't get any errors because of that. Press Shift Enter and we should be good to go. Those 2 points that are basically the start and end points of the line are arguments that are used in the constructor of line counter. So we can see I'm using line start and line end. And one more thing that we need to do is a way to display that line. And for that, we need another annotator. So you remember we had this bounding box annotator that we used to draw detections. And right now we have another annotator that we will use to draw the line. When that is done, we need to let the line know where are the detections so that it can determine whether or not it got crossed by them. And at the very, very end of our main loop, we'll just annotate that line so that we would be aware about the current counter's values. That's it, I guess. And we obviously need to import those 2 important classes. That's it. Now we can just do Shift Enter and wait for the final results. A funny fact about the whole experience is that we spent most time not on tracking, on counting, but on recreating the inference loop. That just shows you how many useful functionalities are buried deep inside those libraries like YOLOv8. I'm not sure about you, but I'm craving for something sweet, and that's perfect because in our second use case, we will be tracking and counting chocolate candies moving on a conveyor. Unfortunately, this time we will not be able to get away with model pre-trained on Coco dataset because there is no class candy in it. Before we can even think about building our tracking and counting pipeline, we need to train our YOLOv8 model on custom dataset. I extracted a few dozen frames from videos that I had and throw them into Roboflow. The annotation was pretty straightforward. Candies are located pretty far away from each other, so bounding boxes are perfect for that use case. I tried to minimize the amount of manual work that I needed to do, so I decided to use augmentation to artificially increase the amount of images in my dataset. I didn't use anything super crazy, just the regular stuff, horizontal flip, a little bit of rotation and shear. All in all, I ended up with around 60 images in my dataset. Not a lot, but given the fact that it's a very controlled environment, I was hoping for a positive result. Now that I have the dataset, I can jump into Google Colab and train the model. We will use the same Jupyter notebook that we used for YOLOv8 Object Detection tutorial. Let's open it in Google Colab and straight away create a copy on our Google Drive. The new notebook will open in a separate tab. We can close the previous one. Make sure that the runtime is GPU accelerated. It is. We will quickly go through the installation process for Ultralytics YOLOv8. We went through it in our previous use case, so there is nothing really new happening over here. Let's skip the CLI, inference. That stuff was already covered in the YOLOv8 Object Detection video, and we can go straight away into training using custom dataset. I can go into my Roboflow profile, sign in, go into my chocolate candy dataset, get the snippet that I can copy into my Google Colab, paste it here, and the dataset will download into my environment, and I will be able to use it for custom training. Now the only thing that is left is to run the training, and I will pick 25 epochs. That should be just enough for such a small dataset. Shift Enter, and let's wait for the model to train. That was really fast training, just like 3 seconds per epoch or something like that. So we can now examine the results just to confirm that our model is behaving correctly. It doesn't need to be perfect, just good enough. Given the fact, like I said, it's a very controlled environment, I don't see a lot of opportunity for false detection. And yeah, in my opinion, that's more than enough for us to use it for tracking. So in that case, the only thing that is still left to do is to zip our runs directory. So let's do it right now. Great. Click download and move to second Jupyter notebook, where we will use those weights to detect, track, and count those candies. For the third time in this video, we are back at Roboflow notebooks. This time we are scrolling once again to computer vision skills and open track and count vehicles with YOLOv8 and ByteTrack, the same notebook that I was mentioning at the beginning of the video. Two things that we need to do at the very beginning. First of all, we need to upload our zip with weights. Second of all, we need to upload the example video that we would like to use for inference. Here is the video, and here are the weights. The upload may take a little bit of time, nothing unusual for Google Colab. In the meantime, we will super quickly go through the installation process. That part, on the other hand, was covered in this video already, so there's no point in going through that once again. I will just update source video path to candies.mp4. And I can continue with installing YOLOv8, ByteTrack, and Supervision. All required libraries are installed and the weights just finished uploading. So we can now unzip them. Let's do that with unzip weights zip. And now we can just switch the path from YOLOv8x 2 runs detect train weights best PT. Let's do it like this. And now load the model to confirm that everything works properly. Here we need to update class ID. There's only one class, candy. So let's do it like this. That's the only one that we are interested in. Shift enter, and that should give us the inference result for a single frame. And if everything will be fine, we'll just run processing for the whole video. That looks pretty promising, I'd say. So in that case, before we can run the processing, we need to think about the line positioning. So I'm thinking something diagonal like this. So we will start maybe at 50-50 and finish in the same place, just on the opposite corner. So it will be 3840 minus 50, 2160 minus 50. That should give us quite a nice location of line. And the output file should be named, I don't know, candy result. Shift enter, and let's execute the processing for the whole video. Now we can use the magic of cinema and just examine the results. Counting works perfectly. It's just a shame that the video that we decided to use is so short and we don't have the opportunity to take a look for a longer time how it performs. Still, I would count that as a success. You can clearly see that we can switch the use case and the model as well as the whole pipeline behaved flawlessly. That's all for today. I hope that the tracking and counting using YOLOv8 is much less terrifying right now. Make sure to like and subscribe and stay tuned for more computer vision content coming to this channel soon. My name was, or should I say is, Peter, and I see you guys next time. Bye.